Hello, welcome to the last part of Module 10. So in this last part, we're going to discuss how can we convert the source code into graph so that we can apply the graph coverage criteria, okay? So just to sum up again, we discussed about this graph-based technique as a structure criteria-based testing technique. And last part of the module, we discussed about how we apply the concept of the graph into software. And then we discussed the coverage criteria based on graphs, such as node criteria, edge criteria, edge pair coverage criteria, and prime path coverage criteria, okay? So we can see that graph is a widely used structure on source code. And the type of graph that we're going to use for this module is called control flow graph. The control flow graph is one of the most common type of graph that we use for source code. And the way that we transform the source code into the graph is the node will be representing the statements. So when you have the node coverage, it means we execute every statement. And the edge will represent the branch in your program. So if you get edge coverage, that means you cover all the branches in the program. And in the next module, we're going to discuss how we apply another type of coverage criteria called data flow coverage to this control flow graph. And then you can have a more finer grain test cases that checks the flow of the data in the graph. So we're going to focus on the control flow graph, which is the graph that we use to represent the control flow of the source code. Okay, so nodes will represent the basic blocks in the code. So basic block means it's a sequence of instructions or statements that always execute together. So how many statements, whatever that you have, if they are executed at the same time, we call them a basic block. And the edge represents the transfer of control. So usually these are the conditions that you have inside the program, which can be if-else statement, can be switch case statement, or can be inside the loop header. Okay, we're gonna see some example after this. So when we have the node, we also have two different special types of node, which is the initial node. So the initial node is the method's entry point, and usually it's the coming into a method of the code. And the final node will represent the exit point. Okay, so initial node will be the entry point. The final node will be the exit point. The exit point can be two things. You can have a return method, a return statement inside a method, or you can have some exception and then you throw the exception. So that is the way that you exit from a method. And decision nodes that we already discussed, it will represent the choices in the control flow, such as if, switch case, or condition for loop. Okay, so let's see an example. I hope this is easier for you to understand. So if we have this code, okay, we have a code with if statement, if x less than y. Then we do these two statements. Else, we're going to do this statement. So we can see that this is a decision. And these two code blocks are executed together. So even there are two statements, but they are inside the same if, and they should be executed at the same time. So this is what we call a basic block. So these two statements will be considered as a basic block. And then you have another branch of the same decision. Okay, so this belongs to the same thing. And then you have another basic block. So when we convert this into a set of basic block, we would have the first one, if x less than y. The second one are the two statements if y, the two statement that y equals 0 and x equal x plus 1. And the last one is the one inside the else here, which is x equals y. What is the initial node? So in this case, the initial node is node 1, or this beginning basic block. The decision node is also node 1, which is the beginning of the graph as well. And we have one junction node. So the junction node means the node that the graph converts to the same point. So this is node number 4, which is not represented by any statement here, but the program finished without anything here. So we need to have this junction node number 4, and that will be the final node as well. So if we represent them as a graph, we would have this kind of graph. You have node 1, which is the initial node. It is also a decision node, so that's why it has these two edges coming out. So if x is less than y, you go to node number 2. If x is more than equal to y, we go to node number 3. And node number 2, you have this basic block. Node number 3, you have this basic block. And then finally, those two nodes converge at node number 4. So with this, we have 4 edges from 1 to 2, which is this one, 1 to 3, which is this one, 2 to 4, which is this one, and 3 to 4, which is this one. So a key things here is that you have to be able to identify the basic blocks correctly and know which one is the initial node, which one is this decision nodes, which one are the junction nodes, and which ones are the final nodes. And then you connect them, and then you can identify the edges. All right. So let's go to see the next example. So this is a pretty similar example to the previous one, but you only have one if statement here, and you don't have any else statement, right? So we follow the same logic as before. So you have this as a first basic block, the if header, and then you have the statement inside of the if is another basic block. So for here, the initial node is 1, decision node is also node 1, and then you have the junction node, which is the third one, the third node that we added so that we can make the two nodes converge, right? So the graph will look something like this. You have node 1, which is also the initial node. It is a decision node as well. So you have two edges going to the left when x is less than y, and another one going to the right if x is more than equals y. When you go to node 2, you have these statements inside those basic block, and at the end, everything converges at node 3. So you have the control flow of 1 to 2, 1 to 3, and 2 to 3. And these are the edges. All right. So the next one, if we have some explicit return statement as this one, okay, what are the graph that we have? So for this one, we have two return statements, this one and this one, right? So if we start by identifying the basic block, you would have this one as a first basic block. The return here inside the if statement is the second basic block. And the last two statements, they are executed at the same time because the print x will print something out and then you go to the return statement right away. And this will become your third basic block. So for this one, the initial node is 1. Decision node is also 1. You don't have any junction node because now we have two different ways to end the program, right? And then you have two final nodes, which is node number 2 and node number 3. If you draw the graph, we would have the graph like this. So node 1 is initial node. And then you go to the left, which means when x is less than 0, you're going to return. So that is one of the final nodes. But if x more than equal y, you have this basic block, you print x, and then you also return. So this is another final node. So you have only two edges here, 1 to 2 and 1 to 3 in this graph. All right. And what about the software programs that have loops, right? So when we have a loop, we might need to add some extra node, or what we call the dummy node, into your CFG graph. And the loop structure might look different depending on the types of the loop, like while loop, for loop, do while loop. And we have to be careful when you go back in the CFG. We have to go back to go to the header of the loop, but not going back to the initial node. Okay, so let's see. If we have a while loop, okay, the program that I show you is very simple one. We have the code with x equals 0, and then while x less than y, we call some function f of xy, and we store in y, and then we have x incremented by 1. So we try to identify the basic block first. So this one goes alone. It is node number 1. The while loop is another basic block. It's the header of the loop. The next one are the two statements that are inside the while loop. They would be executed at the same time. So this one will become basic block number 3. So with this, we have a graph that look like this. You have node 1, which is also an initial node. It is when we initialize x equals 0. And then you have node number 2, which we call a dummy node. Or you can think about it as the while loop header here. Although it doesn't do anything, it just check for the condition, but it is the while header there. And if x is less than y, that means we're going to execute these two statements. So we go to node number 3. And when it finishes, it goes back to the header of the loop, okay? It doesn't go back to the initial node, but go back to the header of the loop. And if x more than equals y, you just return, right? So this is something that doesn't appear here, but if it's out of the loop, then you also finish the execution. So we have the initial node 1. Decision node is 2 because we have 2 decisions here. You don't have any junction node, and the final node is 4. So the edges, you have 1 to 2, you have 2 to 3, you have 2 to 4, and you have 3 going back to 2. Okay, so when we have a loop, we need to make sure that we have this kind of thing, that the arrows going back to create this kind of cycle in the graph. Okay, so if we have another type of loop, which is a for loop, a for loop is actually a complicated type of loop because the for loop header itself, it contains many parts. It contains the initialization part. It contains the condition check. And it contains the incremental part of the loop iterator, right? So these 3 parts, it comes in a different steps. So with this kind of graph, with this kind of program, you would have the first one, initialization comes first. So x equals 0 is the first basic block. And then you have this check of x less than y, which is the condition that happens every single time that you come back to the loop header. And then you do something inside the loop, which is this statement here. How many statements it has, it's going to be executed. And then the last one is the increment. So you will see that the increment come at the last. And the initialization come first, okay? Although we see that in the statement of the for loop, you have everything in the same line, but actually in the execution, they got separated. So with this, we're gonna have a graph like this. So you have loop node number 1, which is the initialization of the loop iterator. And then you have number 2, which is this check of x less than y. So if it's less than y, you do this basic block number 3. So you have node number 3 of y equals the call of function f. And then when it finishes the execution of the basic block inside the loop, you have to do the increment. So this one is another node that you must add to make sure that the incremental of the increment of the iterator is done. And after that, you go back to the loop header again. So you keep doing this loop until the iterator satisfy these condition. And when it's x more than equals y, you quit the loop and then you finish. So node number 5 is the final node that we introduced to finish the execution. So for this graph, initial node is 1 here. Decision node is 2, which is this one. The junction node is also 2 when you have these two edges coming into the same node. And the final node is the node 5. All right. Next one, if you have the do while loop, what is the difference between do while loop and the while loop? Do while loop will execute the loop at least once. Okay. So you must go through the basic block inside the loop at least once. So we have these initial init the same. Okay, you can init the something that you used as a counter, and then you have the do. Okay, so this is the start of the loop, and then you do this basic block inside the loop, and then you have the condition comes at the end. Okay, so with this, we would have the first two statement here becomes the first basic block. And then inside the do while loop, you have another basic block. Also include the header of the while loop, because this thing will always get executed every single time after these two statements, right? And then you have the last one outside of the loop, which is the print y statement. So if we draw it as a graph, you would have node number 1 as initial node with the execution of x equals 0. And then you have node number 2, which contains the basic block and also the loop header, which we show by having these two edges coming out, which is a condition. So when x is less than y, you go back to execute yourself, which is this condition. And if x is more than equals y, we finish the execution and we go to the print y statement. So with this, initial node is 1, decision node is 2, junction node is 2, because you have these two edges coming into the node number 2, and the final node is 3. Okay, the edges 1 to 2, this one, 2 to 2, this one, and 2 to 3, which is this one. All right. So if we have break and continue also inside the loop, what is the difference between break and continue? Break is you quit the loop immediately. But for continue, you skip to the next round of the loop. Okay, so the difference is for break, you quit the loop, but for continue, you skip that round, but you go back and then you try to continue the next round. Okay, so if we have this, let's try to identify what are the basic block. So first you have x equals 0, and then you have the header of while x less than y, so that is another basic block. And then you have these statements that y equal a call of fxy, and you have also the decision of if y equals 0. And then you have the break statement here. And then you have another decision, else if y less than 0 or not. If yes, you're going to continue doing these two basic block, and you have the continue statement here. After that, you have another basic block, and outside of the loop, you have the last basic block. If we draw that as a graph, you would have this initial node of x equals 0. You have the second node containing the while loop header. Okay, so if x less than y, you do this basic block. So y equal a call of fxy, and you also have the if header So if y equals 0, you break, right? You break. Break means you quit the loop, so you go straight to the end and never go back again. But if y is not equal to 0, you have another check. So this one check whether y less than 0 or not. If yes, you're going to do this computation. So we do this node that y equals y multiplied by 2, and then we continue. So this time we continue. So it means instead of going forward, we go back to the loop header, and then we continue the execution in the next round. Okay. But if y is more than 0, you already come to this statement. So you have x equal x plus 1. And finally, you have to go back to the loop header as well, because this is a normal execution of this while loop. And whenever the condition is not met, when x is already more than or equal to y, you go to the last one, which is the print x statement here. Okay, so make sure you understand the difference between break and continue statement, because the graph will look different. Another case is when we have a switch case statement. Switch case statement is a special type of statement in a, let's say, Java programming language. So you read something, you switch the value of that value that you read, and each case represent a condition that can occur. Okay, so if C is equal to N, then you do something. If C equals to Y, you do something. But if it doesn't equal to N or Y, you do another thing. And at the end of each case, you have to break. If you don't break, it will go continue to the next case. Okay, so this is quite confusing code construct. You can get a wrong execution pretty easily. So many people kind of forget to break, right? And then you got a problem that it continues to the next case. So if we draw this as a graph, you would have the first node of read C, and then you have 3 options because you have 3 cases. So if C equals N, you do Y equal 25 and break, which goes to the final node. And then don't look at the red arrow for now. So the next one is if C equals Y, you go to node number 3, which is this one. Okay. And when it breaks, you go to the final node. If you go for the default option, you go to this one. So Y equals 0, and then you break. So the normal switch case statement would look something like this. But let's say if you don't have the break statement, if you forget the break statement in the first case, you don't have this. So what happens is this line, the edge from node 2 to node 5 will also disappear. And you have another edge from node 2 to node 3 instead. All right. So this represents that the execution of this case will go to here, and then it continues the execution to another case. Another kind of potential code that you might have is the CFG that has some exceptions. The concept of exceptions occur when you have some problems or some unexpected execution or output in the code. And in Java program, you throw an exception. So when you got some errors, you throw it to the caller of this particular method so that the error will get caught at the correct location. So in the code, usually when it involves some input and output, like some read line, you may have some problems. So you can throw some exceptions. This one can also have a problem, so you can throw some exception because you might not be able to call s.length, right? But in this case, you check by yourself that if the s.length is more than equal to 96, you throw some new exception and say that it is too long. But if the length is equal to 0, you throw another exception, and then you say that the string is too short. But if the read line itself has any issues, you get IO exception, and then you can print some stack trace to see what's the error. And the last one is to catch any kind of exception that occur. And then you can just get the message and print it out to the console. The last one is if everything goes as planned, you return the string S. So with this case, you have the first node, which is the initial node that reads the value of S. So this is one basic block. So this is the block 1. And so the block 1 contains until the header of the if statement. And then you have block 2, which is the throw of the exception. But if the exception is not thrown, you have another if statement. So that is block number 3. And if the exception also occur, you have the block number 4 that throw an exception. And then you go to the okay, so I'm gonna list the basic block. So this one will be basic block number 1. And when we have some IO exception, we're gonna print stack trace. So I call this block number 2. And then this is block number 3 that we have the if statement. And if the length more than 96, we're gonna throw. So this is block number 4. But then I check for the size of equal to 0 or not. So that's block number 5. And then when we say another, when we throw another exception, this is block number 6. And the last one is when we have this cache. So this is block number 7. And the last one, this is the return, which is the block number 8. And if we draw that as a graph, we would have the first node, which is the initial node, right? If we get the IO exception, we print out the stack trace, which is this one. Okay, so if you come in and if this statement doesn't work, you jump right away to this one. Okay, and if it works, you continue. So you go to node number 3 after that. And if the length is more than 96, you throw this statement. So you go to node number 4. And then if the length is less than or equal 96, you go to another if statement. So you have another if statement here. Check that if length equal to 0 or not. If it is equal to 0, you throw again. So you go to node number 6. Okay. Oh, sorry. In this one, I call it 7. Okay. So this one is 7. And this one is 6. Okay. Sorry, it's a bit confusing. But when we have length equal to 0, we're gonna throw a new exception. So it goes to here. And then every exception, it will come to here. It will get cached here in the cache exception because you throw 2 of them here at node 4 and node 7. It cannot go into this cache because this one waiting for IO exception. So instead, it goes to this cache statement at the end. Okay, so that's why they come to converge at node number 6. And if the length is okay, so if it doesn't go here, it doesn't go here, it will jump to node number 8. So that's why we go to here at the end. Or if we print the stack trace, we also go to here. If we get the message, we also go to here. So the final node will be node number 8, where we return the S value back. Okay. So if you have this code, okay, you have a method called number occurrences. You receive an array of V and you have another character C. The goal of this method is we're gonna count the number of C in V. How many C occurs in V, right? So we start with V. We check whether the V array is null or not. If yes, we're gonna throw some null pointer exception. And then we start the counter n equals 0. You have the for loop, which is 3 parts. And then you check inside the array. And then you increase the counter. And then the final one, you return the value of n. Okay. So let's see what is the basic block here. So the first one is we have this check of v equals now. Okay. The second one is we throw new null pointer exception. And then 3, I'm going to have the initialize of n and also the initialize of I because they occur at the same time. And then number 4, I have I less than v dot length. Okay. And then number 5, I have another if inside the for loop, right? So if v equals c, and then number 6, we have the increment of n. And the last one, don't forget the increment of I. And at the end, we have the return statement, return n. Okay. So initial node is node 1. The final node is node 8. Okay. And for the graph, let's try to draw it. So first we have node number 1, right? If v equals now, then we go to node number 2, and then we throw some new pointer exception. If v is not equal to now, we go to node number 3, okay, where we initialize the n and we initialize the I. And then we check whether I less than v dot length. Okay. We check whether I is less than v dot length. So this is the node of the if header. Okay, so if I less than v dot length, and this one is I more than equal v dot length. If it's less than v dot length, we go to node number 5, which is also another check that vi equals c and vi not equal c. Okay, so if vi equals c, we're gonna go to node number 6 where we increase the value of n. Okay, if it's not, okay, just a moment. If I more than v dot length, okay, just a moment. I should have the node number 8 first. So node number 8 is a final node, right? So if we have n plus plus, so this is n plus plus. And then we're gonna go to node number 7, which is I plus plus. And node number 7 will go back to the loop header, okay? If v not equal to c, we're gonna skip to here, okay? And when I is more than or equal v dot length, we're gonna quit the loop and then we go to the final node. And the last one, when v equals null, we're gonna throw some null pointer exception, right? When we throw null pointer exception and we don't have any cache here inside the code, it will go out of the method and the caller of this method needs to handle it. So that makes the node number 2 also another final node. So we have 2 final nodes here, 2 and 8. Okay. I draw this graph again on the other page, right? So we have a graph that looks something like this. Okay. So let's try to apply the criteria that we learned last time. So if you want to apply the node coverage, you would have the test requirements that contains all the node here. And if you want to satisfy the test, the criteria here, we can find the test path. So the first one is we go this way, and then we visit these two nodes. The next one is we go this way. Oh, sorry. And go back, and then you visit 3, 4, 5, 6, 7, and 8. So just these two test paths, we can cover the node coverage. And at the end, you go to find the test case value that represent such test path. So for the first one, you go to 1 and 2. So that means your V must be null, right? So you select some null value for the V, and for the C, it doesn't matter. So for this T1, you give null and A, and you expect to get null pointer exception. The second one is we want to go in this path, right? So we will come here, V is not null, and then we check whether I is still less than the length of the array. And then you do this, you check once, V must be equal to C as well. So you must give some value that exists in the array. And then you come back, and then you just go back one time, and then you finish. So the length of the array needs to be just only one character, and that character must be the same as the character that's in the variable C. So that's why we have the array of just one character A, and we have the character A given as the C parameter, and we expect the value of 1. Okay. When we want to apply the edge coverage, we have the following test requirements, right? 1, 2, 1, 3, 3, 4, 4, 5, 4, 8, 5, 6, 5, 7, 6, 7, and 7, 4. So the first one that we want to satisfy is 1, 2 again. So we go here, you done that. The second one is we go follow the same path that we did before. This, 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 and this, right? So you cover 1, 3. Sorry, this is 1, 2. You cover 1, 3. You cover 3, 4. You cover 4, 5. You cover 5, 6. You cover 5. You cover 6, 7, and you cover 7, 4, and 4, 8. Okay, you still have this 5, 7 that you haven't covered. So you need another one. So you need to come from 1, 3, 4, 5, 7, and then you can just finish the execution, and that would cover the last one. Okay, we already talked about these two test parts, but the last one, let's analyze it a bit. So the last one is when you have the value of array vi not equal to the character c, and then you just come back one time and then you finish. So you don't actually have more than one value in the array. You have only one single value, but that value is not the same as the character that is given. So I pick the value x, I pick the character a, and I expect to get 0. So that is my test case number 3. Okay. If we apply the edge pair coverage, you have a stronger the test requirements, right? So you have the following test requirements. 1, 2, because you cannot have additional edge here. You can still include only one edge if it's not enough, okay? And then you have 1, 3, 4, which is here, 3, 4, 8, which is here, 3, 4, 5, this one, 4, 5, 6 is this one, 4, 5, 7 is this one, 5, 6, 7 is this one, 5, 7, 4 is this one, 6, 7, 4 is this one, 7, 4, 5 is this one, and the last one 7, 4, and 8. Okay, I can satisfy the first one by going to 1, 2. So this test part, I get rid of this. Another one, I go to 1, 3, 4, 8. So I go to 1, 3, 4, and 3, 4, 8. And the last one, I have to satisfy a lot of edge pairs. Okay, so I go to 1, 3, 4, 5, 7, go back to 4, come to 5, come to 6, come to 7, go back to 4 again, and then go to 8. Okay, so this will cover 3, 4, 5 here, 5, 4, 5, 7, 4, 7, 4, 5, 4, 5, 6, 5, 6, 7. Oh, sorry, I skipped 4, 5, 7 here. 6, 7, 4, and the last one 7, 4, 8. Okay, so the first case is the same as the previous two. The second test case, when we have the 1, 3, 4, 8, right? So we go here to 3, to 4, and to 8. That is when we have exceeded the length of the array. So if we want to just go to here one time, that means it doesn't actually get into the loop, right? So you have the array that is empty, and then you can give any character, and you expect to get 0 output. The next one, you go here, and then the first time you come down, right? 1, 3, 4, 5, 7. So 1, 3, 4, 5, 7, and then you go back again, and then you visit 5, 6, and then you finish. So the first round is when you have the vi, the value in the array, not equal to the character. And in the second round, you have the value of vi equal to 0. So you must have the array that first time it doesn't match, but the second time it matches. So that's why I give x and a, and I also have the character a, and I expect to have the value of 1, which is this pair that match. Okay. The last way that we do is we have the prime path coverage. So prime path coverage, we start by the simple path first, and then we remove the simple parts that are subpart of the other, and then we leave only the prime parts, right? So if we try to derive the simple path, we would get the following set of path. Okay, when I use this exclamation point, it means this path cannot be extended. It already done. Like you finish in the final node, you cannot expand further. If I use this asterisk, that means it is a cycle, and I won't also expand it further. So I follow the steps that we usually do. So we start with the length of 0, and then we go to the length of 1, length of 2, length of 3, and length of 4. When you do the length of 0, you would have 1, 2, 3, 4, 5, 6, 7, and 8, right? But 2 is special because it is a final node, so you cannot expand further. We stop there. 8 is also a final node, so we don't expand further. We stop there. The others we can do. So 1 can be expanded to 1 and 2. It is now already reached the final node, so we don't expand it. 1 can go to 3, and then we cannot go anywhere else. 3, you can go 3, 4, and that's it. 4, you can go to 4, 5, and you can go to 4, 8, which is also another final node, so we cannot expand this one. 5, go to 5, 6, and 5, 7. For 6, you go to 6, 7, and for 7, you go to 7, 4. Okay, so from this, we only go with the one that we can extend. I'm going to mark the one that we will not extend further. And we only keep the one that we're going to extend. So 1, 3, I go to 1, 3, 4. 3, 4, I go to 3, 4, 5. And I also go to 3, 4, 8, which we cannot expand further. 4, 5, I go to 4, 5, 6, and 4, 5, 7. 5, 6, I go to 5, 6, 7. 5, 7, I go to 5, 7, 4. 6, 7, I go to 6, 7, 4. 7, 4, I go to 7, 4, 5, and 7, 4, 8. And then I mark this one cannot be expanded. Oops. Okay, and I keep doing this. So I cannot expand 1, 3, 4, 8. I cannot expand 3, 4, 5, 7. And when I have 4, 5, 7, 4, I already got a loop, right? So 4, 5, 7, 4. So I already got a cycle. So I stopped there as well. 5, 7, 4, 5, I stopped. 5, 7, 4, 8, I reached the final node. So I stopped. 6, 7, 4, 8, I reached another final node. So I stopped. 7, 4, 5, 7, I have a cycle. So I stopped. So I only expanded further these remaining parts, right? And I reach 7. I cannot expand further because if I go back again here, so let's see this one, 1, 3, 4, 5, 7, 1, 3, 4, 5, 7. If I expand further, I'm gonna go back to node number 4, and then I will get internal loop, and it's no longer a simple path. So I stop here. This one is the same. I cannot come back. 4, 5, 6, 7, 4. I already get a cycle. I mark here. Cannot expand because we'll get internal loop. Okay. This one also a cycle. This one is also a cycle. This one you reach the final node. This one is a cycle, and this one is a cycle. So after this, you can see that we have only last one, which is length equal to 5, that we can expand from this one. So from this one, we expand to 1, 3, 4, 5, 6, 7. And then we cannot expand further as well because we're going to get the internal loop. Okay, so after this, we get rid of the final nodes that are subparts of the other final nodes. And we would have the prime parts remaining as following. Okay, and when we have this prime part, we think about the test part. So I have the test part 1, 2, 1, 3, 4, 7. So let's try to mark them. So 1, 2, this one, you cover this one. I have 1, 3, 4, 8. So I cover this one. I have 1, 3, 4, 5, 7. 1, 3, 4, 5, 7. 4, 5, 7, 4. 4, 5, 7, 4. 7, 4, 5, 6, 7. Okay. And I think that's it. Okay. So the next one is 1, 3, 4, 5, 6, 7. 1, 3, 4, 5, 6, 7. 4, 5, 6, 7, 4. 4, 5, 6, 7, 4. 5, 5, 7, 4, 5. 5, 7, 4, 5 is here. 5, 7, 4, 8. 5, 7, 4, 8 is here. 5, 6, 7, 4, 5. 5, 6, 7, 4, 5 is here. 5, 6, 7, 4, 8 is here. 6, 7, 4, 5, 6 is here. And 7, 4, 5, 7 is this one. All right. So this one is a little bit complicated, but you can find 5 test parts, and then it's going to cover all the prime parts that you have. And then, yeah, using the techniques that we discussed before, you check what should be the test case value, how it goes inside the loop. This one is like one time doesn't match. This one is one time match at the first one. This one is, sorry, this is 2 times match at the second one. This is 2 times match at the first one. And this is 2 times match both of them. Okay, and then you have these following expected value. All right, I hope that is good for you to understand. And with with this, we complete the whole thing that we can transform the source code into the graph, and we know the graph coverage criteria. So we apply the graph coverage criteria to the program, and then you can get the test cases to satisfy the test requirements. That is all for module 10, and we're going to see you in the next module.